Dear students, today we are discuss about the topic electrostatics. What even electrostatics? The electrostatic is the branch of physics. It deals with static electric charges or charge at rest position. What even electrostatics? The electrostatics they called frictional electricity. Some example in 600 BC, the Greek philosopher Thales, the first find out the observe the ampere. When a piece of ampere is rubbed with fur, after rubbing, this object attract with light object like small bit of papers. In 17th century, William Hilbert, the scientist, the find out glass, ebonite, etc. Okay, also exhibit this property when rubbed with suitable materials. The substance which acquire charges on rubbing are said to be electric field or charge the electricity produced by friction. This friction called frictional electricity. If the charge in the rest position at K producing from electric field, then the friction is known as the static friction. Okay, next one, charge particles. The charges are classified into two categories: one positive charges and negative charges. The first find out from the Benjamin Franklin. Okay, next here, the like charges refill, unlike charges attracted. Here some example: one positive charge and then positive charge. There are two charges refer to each other. Okay, next one, negative charge and the negative charge. There are two charges, same charges or like charges repel each other. One positive charge and then negative charge attract to each other. One negative charge and then positive charge attract to each other. Here, next one, electric charge. The electric charge means electric charge SI unit coulomb. And charge of electron 1.6 into 10 power minus 19 coulomb. Here, Q is equal to Ne. What do you mean Q? Q is the charge, N is the integer, E is the charge of electron. Okay, next, the electrons, the charge particles carry the electrons. Charge particles carrying the electrons. Here, Q is equal to Ne. In the universe, all objects are made from atoms. The atom consists of proton, electron, neutrons. And these particles have mass charge carried by electron. The electric charge SI unit coulomb. Charge of electron 1.6 into 10 power minus 19 coulomb. Next, second property is conservation of electric charge. What do you mean conservation of electric charge? Electric charges can neither be created nor destroyed. According to the law of conservation of charges, the total charges is an isolated system always remains constant. The charge can be created or destroyed. The total charges remain conserved. Some example: uranium, atomic number 92, mass number 238. Okay, here before decay. The after decay, the uranium convert to thorium. Here atomic number 90, mass number 234. Here emitted the helium particles, some other alpha particles. Here the total charge before decay 92. Okay, next after decay, charge particles 90 plus 2, 92. Here in the charge system, after decay, before decay, there is no change in the atomic number. Okay, next the third property is quantization of charge. In nature, the electric charge, if any system, is always an integral multiple of least amount of charge particle. Here Q is equal to Ne. N is the integer. N is equal to 0, plus or minus 1, plus or minus 2. The charge of electron 1.6 into 10 power minus 19 coulomb. charge of proton 1.6 into 10 power minus 19 coulomb. Here charge of electron, charge of proton, the values are same. Here only the negative charge and the positive charge. Next go to from Coulomb's law. What do you mean Coulomb's law? The Coulomb's law, let us consider the two charge particles, one positive charge. There are one charge q1 and the charge q2. There are two charge particles separated by a distance small r. Here some example, and the q1 is the positive charge and then q2 is the positive charge. Okay, there are two charges are positive charges. Okay, here now already known the like charges repel, unlike charges attracted. Some example here, positive and then negative between the forces, attracted force. Here positive and positive, what the forces between them repel. Okay, in the Coulomb's law, the force between two charged bodies was studied by Coulomb in 1786. The force of attraction means the unlike charges produced by attraction. The force of repulsion, there are same like charges produced from repulsion between two point charges, is directly proportional to product of two charged particles. Force directly proportional to product of two charge particle, one charge q1 and then q2. Okay, next here producing force F. Here producing force F. Okay, next between the distance, what a distance or distance. The force directly proportional to product of charge. The force inversely proportional to square of distance. Okay, distance called R, square of distance. Equation 1, equation 2. Okay, next from equation 1 and 2, the force directly proportional to product of charges q1 by q1 q2 inversely proportional to square of distance. Here remove the symbol. F is equal to k q1 q2 by r square. Here k is the proportionality. K is the proportionality constant. Here k is equal to 1 by 4 by epsilon naught. 1 by 4 by epsilon naught. What do you mean epsilon naught? The epsilon naught is the permittivity of free space. This value 8.854 10 power minus 12 coulomb square Newton meter minus 1 meter minus 2. Okay, here epsilon naught means permittivity of free space. This value 8.854 into 10 power minus 12 coulomb square Newton minus 1 meter minus 2. Okay, next here Coulomb's law again called, and the force of attraction or repulsion between for two charged particles is directly proportional to product of charges inversely proportional to square of distance. Okay, next from the equation 1, called F is equal to k value 1 by 4 by epsilon naught q1 q2 by r square. Let us consider the Coulomb's force. Okay, next here this value, one magnitude of electric force between the terms. The charge q1 q2 is equal to 1 coulomb. The distance r is equal to 1. This value applying the equation 2. Okay, here F is equal to 1 by 4 by epsilon naught. q1 value is equal to 1, q2 value is equal to 1. Here r is equal to 1. Okay, next F is equal to 1 by 4 by epsilon naught. 4 by epsilon naught. Here applying the value 1 by 4 into 3.14 by value epsilon value is equal to 8.854 into 10 power minus 12. This value substitute here produced from 9 into 10 power 9. Okay, here the force value F is equal to F is equal to 9 into 10 power 9 Newton. Here 1 coulomb. What do you mean? 1 coulomb. 1 coulomb is defined as the quantity of charge when placed at a distance 1 meter. Placed at distance 1 meter. Placed at distance the quantity of charge 1 coulomb. Okay, in the distance 1 meter in what's the medium? Air medium or vacuum from equal and similar charge experience a force 9 into 10 power 9 Newton. That's called 1 coulomb. Okay, next.